Okay, everyone. So in the previous video, we learned how to find the domain and range of rational functions. Now, in this video, we will discuss how to find its vertical asymptotes. Okay. So if you take a look at this graph right here, so if you remember, this is the graph of f of x is equal to 1 over x squared. So you see right here, the graph approaches but does not touch the y-axis, right? So it is um, so the graph is approaching the y-axis from the right and from the left, right? As x approaches 0 from the right and from the left, but it never really touches x is equal to 0, right? Because if you take a look at the graph, I mean at the function right here, if x is equal to 0, then the function will be undefined, okay? So that is actually how we define a vertical asymptote. So 0, x is equal to 0 is a vertical asymptote of this function. Okay, so let's read here how to find the vertical asymptote. So if f of x is equal to p of x over q of x is a rational function in which p of x and q of x have no common factors. Okay, so that means we've eliminated their common factors, and a is a 0 of q of x, then x is equal to a is a vertical asymptote of the graph of x. Okay, so what this states is just we need to find, in order to find the asymptotes, we just need to find the zeros of the function, of the denominator of the function. Okay, so let us try to find the vertical asymptote of this first item right here. So we have here f of x is equal to x over x squared minus 9. So what values of x makes this denominator 0? So in order to find that, let us equate this to 0. So we can factor this out to be x minus 3 multiplied by x plus 3, right? Then using the zero product property, we have here x minus 3 is equal to 0, x is equal to 3. And then x plus 3 is equal to 0, x is equal to negative 3. Okay, so the vertical asymptotes are x is equal to 3 and x is equal to negative 3. So those are the vertical asymptotes. So let's take a look if those really are vertical asymptotes. Okay, so as you can see here, if we zoom in, so this is the graph of our function. So at x is equal to 3 right here, so it is an asymptote. So the graph only approaches it, but it never touches it. So as you can see here, this is negative 3. So it's the same thing. Okay? So let us now proceed to the second item. Okay, so this second item is a little bit different because as you can see here, if we factor out, so if we factor out the denominator, which is x plus 3 multiplied by x minus 3, we can cancel out x plus 3. So we are left with 1 over x minus 3. Okay, so in order to find the vertical asymptote of this, we just need to find what makes x minus 3 equal to 0. So x minus 3 is equal to 0, that would be x is equal to 3. So this is your vertical asymptote. Now let's check with the graph if that is really the case. So where was that again? 1 over x minus 3, right? So there you have it. So we have 3 right here, and it is an asymptote of the graph. So the graph just approaches it from the left and from the right, but it never touches it. Okay, so let's now go to our last example. So we have right here x plus 3 over x squared plus 9. Okay, so can we factor out this denominator? No, right? So we cannot factor that out. And then, so we cannot cancel out this x plus 3. Okay, so what real numbers can you think of that will make the denominator 0? So are there any? So it turns out that there is none, right? Because no matter what real number you choose, this will never be equal to 0 because it's squared. And if you choose negative numbers, so it will get squared. So yeah, so you cannot find any real number. So we can say that the domain of this function, domain is the set of our real numbers, right? Okay, so this particular function has no vertical asymptote. Okay, this has no vertical asymptote. Okay, so thank you for watching, and I hope you learned something new in this video. See you in the next ones.